Hello everyone, I am Aisha Ilyas Shamshapre from Sri Siddheshwar Women's College of Engineering, Sholapur of Computer Science and Engineering in SYB, roll number 218, and today I am here to speak on a topic of operating system, that is multi-threading modules. So let's see what is multi-threading and why it is important. Multithreading is a programming and execution technique in which a single process creates and manages multiple threads of execution within itself, allowing multiple tasks to run concurrently. Each thread is a lightweight, independent unit of execution within a process that shares the same memory space and resources of the process but runs independently. The importance are improved CPU utilization and application responsiveness. Benefits are faster execution and better resource management, and also enables parallelism. The next, there are two levels of threads, that are kernel level thread, that means managed by OS kernel, supports true parallelism, slower creation and switching. Second level is user level thread, that is managed by user libraries, faster context switching, limited by single kernel thread. And next we have to see, there are three modules of multi-threading. The first one is many to one, that means multiple user level threads are mapped to a single kernel thread. How it works: thread management is done by the user level thread library, and the kernel is unaware of the presence of multiple threads. As we can see in the picture also, the many users are connected to the one user thread, that is kernel. And there are also advantages of many to one module are simple and low overhead, efficient thread switching in user space. The disadvantages of many to one module are: one, blocking thread blocks all, no true parallelism. Use cases are systems with limited threading needs, environments privatizing simplicity. The next module is one to one module, that means each user level thread maps to one kernel thread. How it works: the OS provides support for thread creation and management. And also the advantages of one to one module are: more concurrency, if one thread blocks others can still run, and can run in parallel or multi-core processors. And disadvantages of one to one module are: more overhead due to kernel involvement, limited number of threads due to system constraints. The examples are Windows, Linux. And in strengths of one to one module is allows true concurrency and parallelism. There are also weaknesses of one to one module, that is high overhead creating many kernel threads. The next and third module of multi-threading is many to many module, that means many user level threads are mapped to a smaller or equal number of kernel threads. How it works: the system allows many user threads to be multiplexed over a smaller or equal number of kernel threads. The advantages of many to many module are: combines the benefits of many to one and one to one modules, allows the OS to create a sufficient number of kernel threads. The last, better scalability and flexibility. The disadvantages of many to many module are: more complex to implement, overhead in managing mappings. The example is some customized Linux or NPTEL implementations. The efficiency is optimizes resources used by sharing kernel threads. Complexity is scheduling mechanisms uses found in advanced OS. And then exploring the two level module, that is hybrid nature, combines benefits of many to many and one to one modules. Flexibility allows application threads to be bound or unbound to kernel threads. Example is used in modern Unix variants. And the last, choosing the right multi-threading module is workload type. Consider its CPU bound versus IO bound task. System resources. Evaluate evaluate memory and processing power limits. Application needs balance complexity, performance, and responsiveness. OS support. Check kernel level features and thread management options. And to conclude, I have to say, the is multithreading is a powerful technique in modern computing that enhances the performance and responsiveness of applications by allowing multiple threads to execute concurrently within a single process. It efficiently utilizes CPU resources, especially on multi-core systems, by performing multiple tasks in parallel. Different multi-threading modules, many to one to one, and many to many, offer trade-offs between simplicity, performance, and system resources usage. The choice of module depends on the application's requirements and the operating system's capabilities. So this is all we have seen about the multithreading and modules of multithreading. Thank you.